So hello everyone, this is the channel about engines. Today we're going to assemble this engine. It's a Mercedes-Benz OM501. This engine was taken from a vehicle like this. The engine belongs to my subscriber from Moscow, from a truck, a dump truck, basically road equipment. I disassembled this engine in November, in the fall. Now it's spring outside and I'm just starting the assembly. So why did it happen this way? I'll explain briefly now. Well, first of all, it's the machine work. The engine was taken from machining back at the beginning of December, and I only got it back from the machine shop at the end of February, or even the beginning of March. I don't even remember exactly what was the problem. Well, first of all, this engine was repaired last spring, a year ago in Moscow. They tried to machine the seat for the main bearings, but after the repair, constant problems started. The engine still didn't work, so it was disassembled again. Hence the crankshaft matched connecting rod weights and reassembled it, but it still ran poorly. There were some strange noises. It was shaking and so on. So what was the problem? Were the valves hitting the pistons? But during the last repair a year ago, they replaced the camshaft. They bought it somewhere in Europe, I'm not sure. But that's what the customer said and what I remember, so what's my opinion? Well, the repair we had wasn't very good. Let's say, first of all, the urgent work was done so-so. Well, in general, our machinists were really shocked by this unit. After all the years they've studied and all the work they've done with it, they said they'd never seen anything like it before. That's the first thing. And the second is that the camshaft was chosen incorrectly. I want to check that again now. Over there is the old camshaft that used to be on this engine. We also bought a new one more than 3 months ago. It's this 9. Now I'm going to measure the cam height. I'll put the camshaft on a prism with a triangular indicator, check the lobes and so on. But before that, let's do something else. The customer is already unhappy that the repair has taken so long. But in any case, I tell him that after your guys messed things up, our machinists did everything they could. And as usual, there's a line for the machinists. But what else is the problem? What we see here is a type engine, and the cylinder head mounting surfaces are at an angle to this plane. So, for those who understand what I'm talking about, it's difficult to set up the cylinder head mounting surfaces for machining. And that's why we send the engine to the factory for this job. It's not easy to get it done there, either there's a queue and so on. That's why the customer is already unhappy. Well, what can I say? Unfortunately, things can be done quickly and well at the same time. Or at least, I don't know how to do it that way. So, after the engine came back to us from the machining work, about 3 weeks have already passed. Well, I couldn't just drop my job and I didn't even know when it would arrive or anything like that. I had my own work going on there. And when this block arrived, I had the 9 disassembled. Well, obviously, I needed to assemble the engine, send the car off, and now I'm starting to repair this engine. So, as for the setup work, what did we have? The seating for the main bearings, also replacing the camshaft bushings and machining the camshaft bushings, also machining the cylinder head mating surfaces, and we also finished the seating for the liners. So basically standard set, a complete set for the 501 engine. We can also see that the covers were ground, yes, because there were issues with that too. They also ground the seating areas here and on the cover, on the block itself, but that's literally just a few hundredths, maybe tenths of a millimeter. A lot of work was done. They also replaced the guides. Here we have guides on these covers, and the guides were also worn out and damaged. But they also made these holes a bit lower, because a lot had to be ground off the cover in this area. So the cover sat lower, and as a result the threads didn't line up. Well, it's just a matter of tenths of a millimeter, but in any case the bolt would go in at an angle and wouldn't press the way it should in general. We made these holes and also set them a bit lower. I don't know what we'll end up with regarding the block. There were a lot of questions after the previous machining work. I mean, our machinists did everything they could. But in any case, I'll only see all of this when I start assembling the engine. I told the customer about this back when I was disassembling the engine. I said that to be 100% sure, the block needs to be replaced, meaning you need to buy either a separate block or a complete engine assembly and then assemble it. But the customer said we should work with this block, so we've basically done everything we could. But I don't know how it's all going to turn out now. Let's hope everything will be fine. So, what are my next steps? Let's start. As usual, I open up all the oil channels, blow them out, clean all the channels. Okay. Then I'll clean the block here as well, just like always. So let's get started. Before installing the camshaft, we'll first take measurements, then install the oil nozzles, then install the camshaft. After that, we'll install the crankshaft. Next, we'll need to work on the pistons. For the pistons, we'll have to measure how much each piston protrudes above the cylinder block, and then individually trim each piston a little on a lathe. But basically, that's all standard procedure too. We'll also have 5 new cylinder heads. I think it's the first time we've had brand new heads, meaning they're already fully assembled with all the valves, seals, rubber parts, springs, and so on. But the customer asked us to disassemble these heads, remove these seals, and install Erling-made seals. Since the customer asked, of course, we'll do it all. So we have 5 new heads, and 1 head was replaced last time when there was a repair in Moscow a year ago in the spring. There was also a new head, but I also lapped the valves on site there, and I'll also install the seals and assemble it here. Let's say we have a turbine here after electrical equipment repair. Also after an overhaul, we'll also have 1 new connecting rod that the customer sent. He had some BF brand connecting rods left over from the last repair, but I don't know who watches my channel. I try not to use BF connecting rods, well, because there have been a lot of cases where they get stretched and the bearings get welded, so I've had such cases more than once. Specifically with connecting rods made by BF. That's why I explained to the customer and said that it's not really advisable to use them. Of course, I can install them, but as for what happens later, I won't take responsibility for that. So here we are. As a result, 1 connecting rod from original equipment was purchased. And for the other 5 connecting rods, the piston pin bushings were replaced. So that's what we have. It's an interesting engine, but redoing someone else's work is not exactly enjoyable. I already regret taking on this engine repair. The customer is already unhappy and so on. There's now a lot of responsibility to fix everything. I need to make sure that this problem won't happen again, that the valves won't hit the pistons. In any case, my explanation is the same. The valves were hitting the pistons. It's only because of the camshaft. Now, the camshaft has been selected according to the vehicle identification number. The supplier handled it, and he said that the previous camshaft wasn't from this engine. In any case, I'll check all of this again now. So, I ended up with a rather long introduction. Well, I also have some emotions and concerns about this engine, so that's how it is. So, that's the scope of work we have. Let's start assembling. Let's go. I finished working with the block, cleaned it, blew out all the channels and thread several times, and so on. The block is fully prepared and I can start assembling. First, I close the oil channels, install the plugs, and then install the oil nozzles. Next, I'll probably install the sleeves right away, then flip the block over, install the camshaft and the crankshaft. After that, we'll work with the camshaft, measure the piston protrusion above the block, install the pistons one by one, take measurements, go to the lathe and do some machining. It's a pretty labor-intensive job. I also rinse the gear covers again. This is the crankshaft gear, the timing gear and the compressor drive gear. I washed everything again, prepared the plugs, and now I'll check if I need to replace a washer somewhere, and also the oil nozzles. I blew everything out and checked these holes here just in case any of them were clogged. Well, I mean, the lifter that spun and wore down the cam lobe. In that case, it wasn't because the hole was clogged, but because the key on the lifter itself fell out. It's a common issue with these engines, so I checked all the injectors as well. I also blew them out, cleaned everything, and made sure that we have checked everything and confirmed they're clear. So, let's start assembling the subtitles. So next I unpacked the piston assembly. The piston assembly was purchased about 2.5 or maybe even 3 months ago, right after the purchase. I opened it right away, checked if the sleeves and pistons were good or not, weighed them and so on. That's why I have the sleeves here, and the pistons and everything else are in that box. Now we're going to unpack everything and install the sleeves. So the lightest piston we have weighs 4.0, and there are 2 pistons like that, the first and the fourth, and the heaviest piston we have also weighs 4.0. So the weight difference is 7 grams. For pistons like these, that's just perfect, considering that the piston rings pin and clips together weigh over 4 kilograms. The weight difference is just 7 grams. That's just a few tenths of a percent. the sleeve protrusion above the cylinder block. We set up the indicator. We see the block is at 0 and the sleeve is 3/10, 0, 3/10. That's the upper limit for this engine. So all the sleeves, I've already checked them all. The protrusion is 3/10. Now I'm taking out the sleeves, installing the rings, and then I'll install the sleeves into the block. So I compared the two camshafts. This is the old one that was installed on the engine, and this is the new one that was bought and matched by vehicle identification number code. So what's the difference? Well, just like with the camshaft during disassembly, I don't remember if it was on video or not. I was comparing it with the camshaft not from Euro 5 but from Euro 2. I think it was the same there too. I had this cam lobe, there was an offset. So for example, I set the timing mark according to the timing belt mark, and we can see that on the old camshaft, this cam lobe lines up exactly with the mark, and it's divided exactly in half. So you can see it's symmetrical. But on the new camshaft, we can see that the cam lobe is shifted more to this side, meaning the lobe is farther from the mark. And it's the same if we look at the first cam lobe. From the gear where I took measurements with the dial indicator, I marked the highest point on the gear that the dial indicator showed me. So we can see that there are these pins on the camshaft. These are for the camshaft sensor. We can see they're evenly spaced, and in one spot there are two of them. This way, the sensor understands that at this point the camshaft is in a certain position, thanks to these pulses from the electromagnetic sensor. And we can see that the highest point of the cam lobe of the first pin is, if we look from this side, to the left of one of these protrusions. And now I also compared it on the old camshaft, the highest point that the dial indicator showed me. I also made a mark, and we can see the highest point on the old camshaft. The first cam lobe from the gear is on the right. So once again, on the new camshaft, it's the tooth on the left. On the old camshaft, it's the tooth on the right. And also, I counted from the timing marks. We got 29 teeth. That's 29. On the new camshaft, from the timing marks, we got the 30th tooth. And that's correct. The gear is shifted further in this direction. So the cam lobe, the mark on the cam lobe is also shifted in this direction. I'm cleaning the new camshaft from the preservative. It was already at the machine shop, meaning it was taken to the machinist. They were fitting the bushings for it, and as we can see, they've already removed the grease, the preservative here, but the cam lobes haven't been touched yet. So now I need to clean all of this with a special solvent, and then I'll be installing the camshaft in place. And I also have the crankshaft prepared. Now it needs to be blown out. I've already prepared the bearings and the thrust washers, so after I install the camshaft, I'll move on to installing the crankshaft. cheese. Alright, so I want to show you another important point. I was also worried about this, wondering how it would turn out for us. So I installed the camshaft, installed the crankshaft, and aligned the timing marks. Here, the gear just fits onto the shaft. Ooh. And then it's tightened by the flywheel and the bolts that secure the flywheel, which also press this gear in place. Since the block was already machined last spring, the shaft sat a bit lower. Now the machinists have worked on it again, so the shaft sits even lower. So I was wondering if there would be any gap in these gears. So I installed everything, made sure to tighten the gear, because it needs to sit in place. If it's not tightened, it could shift a bit, and so on. I definitely tightened the gear. And now let's take a look. So as we can see, there is a gap. Of course, it's smaller than in a standard engine that doesn't have machined beds, but in any case there is a gap, and that's the most important thing. I'm 99% sure there won't be any problem, so everything should work just fine. I was afraid that if the crankshaft and camshaft got stuck together, then we'd be in a hopeless situation. I don't even know what we would do then. Well, it's about a tenth, even less than a tenth, about 78 hundredths. There's a gap. Well, there's nothing we can do about that anymore. I mean, there's no way to fix it. It already depends on the block when the customer disassembles the engine. I've mentioned this several times, that to be 100% sure about the repair, you need to replace the block. So I suggested either buying another engine or just finding a block. But the customer didn't agree. He said this block would still work for a while, even before handing over the block. While the block was being machined, I called the customer and once again emphasized, I made it clear that once again, I'm saying there could be problems with the block. I also installed the front cover, put in a new seal, used a gasket with sealant and tightened the rear cover. The compressor isn't ready yet. Just recently the customer paid for the crankshaft. Well, basically for the compressor parts. They just arrived recently, although this could have been done earlier. I don't know. 2 months ago we could have assembled this compressor. But while we were waiting for the flywheel block, I still had work to do. I need to assemble the compressor. So now I'll work on the connecting rods. We have one new connecting rod. One was rejected by the machinist. And we have 5 connecting rods. After the repair, as usual, we first checked the seats for the connecting rods and the bearings for deformation. Well, basically everything is fine here. The piston pin bushings were replaced and machined. So, what's my task now? Oh, and I also want to mention that these connecting rods were once matched by weight. You can see here, they were ground down on a grinder, so the weight of all 5 connecting rods is about the same. My task now is to see how well the new connecting rod matches the weight of these connecting rods. Well, if it's heavier, maybe I'll make it a bit lighter by grinding it down as well. If it's lighter, well, I don't know. I'll just leave it as it is because I never really adjust connecting rods. Basically, everything works without any problems. In all my practice over 20 years, I've never done anything like that. Grinding down any caps or anything like that, I don't know about that. I'm unboxing a new connecting rod here, taking off the caps from these rods. They're currently tightened to working torque. Next, I remove the piston rings from the pistons, and as I mentioned before, we take measurements and adjust each piston for height. So, As we can see, the new connecting rod is heavier by 30, 44 grams, 45. Well, now I'll try to grind off a little from the cap here, maybe from this spot. That is, I'll remove these 40 grams so that it matches in weight. Well, since it's already done this way here, I ground off literally half a millimeter in this spot, and also from the cap here on top, and just a little bit from the side. So let's wait. Well, 3672. These are at 3671, so that's 2 grams. We won't even pay attention to that, so let's consider the connecting rods already matched by weight. Next, we'll work on the pistons. Alright, so I installed a piston for the second cylinder, the second piston, and measured how much it sticks out above the cylinder block. As we can see, the block is at 0. So the block is at 0, 0 a small, and a large 0, and the piston is at 7/10. Here, the lower part is 6/10, or rather, the lower part is 5/10, and the upper part is 7/10. Well, because it doesn't have rings, it falls under its own weight. So, the average is 6/10. The piston protrusion above the cylinder block is 6/10. Well, in theory, that's kind of our upper limit. Here it goes up to 0.61 millimeters, which is 6/10. It seems like we could leave it as it is, but I'm not sure. I'll take a look now. I'll probably install these two pistons and take some measurements. Well, maybe here we have from 0.3 to 0.6 millimeters, but I actually wanted to make it 0.3, which is the lower limit. I don't know. Wait, I'll think about it now. Maybe I'll install the cylinder head, put some paste there, and take measurements to see the distance from the valve to the piston. Basically, how much the paste gets deformed. Then I'll make a decision based on that. So, let me briefly tell you how things are going and what I'm working on right now. There were some shots. I trimmed 2 more pistons. That's the first and third ones. I took off 3/10 from the first, second and third pistons. Well, and there I have about 30 something hundred, so it's almost at the upper limit. So now I'm going to install these pistons back in place, put on the piston rings, the connecting rod, and then put the pistons into the block. After that, I'll turn the block over to the other side, and then I'll work on the other side, meaning the 4th, 5th and 6th pistons. I started with the 2nd piston, same process. So I took measurements, showed them on camera, installed it without the rings, took measurements, honed it, then put on the piston rings, the bearings, greased everything, installed the piston into the sleeve, and then same as before, took measurements, set the pistons on the cylinder block and continued from there. What I did was install the head. We have a new head. I installed the push rods and I used the old gasket that was previously installed on the engine. I put these markers on each valve and installed the rocker arms, adjusted the valves. I tightened the head, installed rocker arms, adjusted valves and turned the engine over so that my valves would work, so that the piston would move back and forth. We see this kind of gap. Thanks to these markers, I can see what gap I currently have between the valve and the piston. That is, we see, well, give or take, it's about 1.5 millimeters. Somewhere it's more, somewhere it's less, but roughly 1.5 millimeters. We have a gap. Well, in any case, I needed to check this, take a look and make sure for myself once again, because as I already said, I have a lot of doubts about this engine. Well, now I see that everything is definitely fine. There won't be any problems. 1.5 millimeters is more than enough for the thermal gap, for any possible clearance for carbon buildup and so on. That is 99.9%. I'm sure there won't be any problems with this engine. Well, I mean, the problem that was with the valves, yeah, that won't happen. That's it. So now, well, obviously I'll remove all this stuff I've put on here, clean up the piston. There are still some marks left. I'll get rid of all that, clean it up, and as I've already said, I'll install these 2 pistons. Today, I definitely need to finish with the pistons. Maybe close the rear cover. The front one I've already installed. Close the rear cover and assemble the compressor. So, the customer calls and asks why everything is taking so long. Well, it's just a big amount of work. Let's continue.